All right, I won't repeat that very long title. Our moderator already did that. So I'm from the University of Technology, Jamaica. I am an instructor in the School of Engineering, and I'd like to speak today a bit about how I create engineering questions using a XML file generator that will be imported into Moodle. Now, let's say 15, 20 years ago, this is a typical setting or a typical picture of what an engineering student may look like doing an assignment. And what's important is, as we go forward, there are certain elements of engineering education, and I'm thinking physical engineering, because there's also digital and other spaces. What in physical engineering, chemistry, physics, biology, environmental matters. There's a physical element to engineering, and so there's a need to capture some things and maintain some things while we're improving and transitioning or adapting to the digital space. So this is what a typical set of students today may look like doing an assignment, for example. And yes, we see laptops and phones, but still, more often than not, you'll still see books and pens and paper, because that's part of the experience of an engineer in trying to solve problems. So we're really concerned about how we digitize type of assignments that an engineering student typically sees or has to deal with. So let me just quickly go through what we call a textbook engineering problem. And that word textbook is a noun, meaning a textbook, but it's sort of an adjective too. When you say that's like a textbook bus, you're just saying it's a standard, right? But I figure this word textbook will always be around, and it will transition from being a noun to an adjective, which means the standard. So even though textbooks will disappear, there'll still be a textbook problem that we're dealing with. This is an instructor from Stanford University. He says here that science and engineering education, one goal is to produce problem solvers. Okay? And another from University of Florida mentions two statements or two types of problems. One is called ill-structured, and the other one is well-structured. And ill-structured doesn't really mean bad. It just means sort of not clear, or not. It depends on the problem solver to find the structure, to find the approach. And so a facilitator of learning has to guide really an engineering student to become solvers of ill-structured problems, because they're learning to be solvers, right? And so the classroom problem, oftentimes we make it well-structured, but in the workplace, problems are ill-structured. And so we have to learn more of how to make our problems in the classroom have flavors of ill structure also. So here is sort of the evolution or the growth of an engineering student as they go through their years, a typical bachelor's into the master's years. So at first, an engineering module or course may give questions, assignment questions that may have one or two parts to it, very explicit, very clear questions with sometimes the approach to solving the question is very clearly stated in the question, because these are younger students and you're trying to hold their hand through a problem. And You may even suggest a formula or hint, more than hint sometimes, at the formula, and there's a clear answer. But as they mature through their years, you start giving longer questions which have multiple parts, and each part has its own value or weight in the question. It may involve several formula or several approaches, and you may not really hint at the formula, at the approach anymore, or what formula you're to take or to use, but you still may have specific answers for solving the questions, for each question. But by the time you become a final year student, there is no answer that's right. You're a solver. You are supposed to craft the problem, and you're supposed to present a solution. You're not telling me what I'm saying the solution is. You are giving me a solution. And this is ultimately where we want our graduates from our engineering course of study to be able to perform. I'm not here yet with Moodle, but we are looking at this type of question, which is what we call the textbook question. So let's look at what a question like that looks like. So I'm taking this from a course I teach called Heat Transfer. It's actually taken from the textbook. And these are common elements to a textbook question, textbook engineering question. So you have parameters, quantitative information, which may be in a text body of the question, or it may be in a diagram. So it's common for engineers in the physical engineering sciences to have to use diagrams, right? To picture what they're talking about. And as I said, in the intermediate stages, it's not a one answer thing. It may be several stages to a question, several elements to the question. So here we have 4 parts shown here. And no format in Moodle explicitly, of the question format in Moodle, explicitly creates questions like that, but the ability is there, possibly using the close format. So what I've chosen to do is see if I can reproduce that type of question that the student would normally see in a textbook. And here's an example of that type of question that was done in UTech Online. That's the platform used by my institution. So as with a textbook question, we have a diagram. What I haven't been able to figure out as yet is how to put quantitative information on the diagrams, which can be dynamic. That means the numbers can change. That's on the diagram. But what we have here is the main question, and again, parts, several stages for each question. And using the closed format, students can input their answers to the questions that way. So what the tool that I've used does, here are some other options. So this here integrates the tech format to put equation type questions here. Each part of the question can also have several prompts for answers. And in this case, I have 9 prompts in these 4 parts to this question. And here's a more involved question. This might now start to approach what a more mature engineering student would have to deal with several parameters. You are given a scenario, but you're not really told how to approach, how to solve all of these problems. But what this type of approach does is it aids in teaching procedure. So let's say I want the student to be able to get all the way here. I give them those several parts, and as they go through, they mature in that procedure. So let's go back to the first one, the first example of our textbook problem that we have for UTech Online. So the formats used, for those who don't know, I think some of you may know how to do numerical formats with GIFT. It's sort of similar. Close is a format that allows you to embed different responses within regular text in a question. So it doesn't have to just be boxes to input information. It can be dropped down. Any of the other type of interactions that Moodle question formats allow. And I showed you earlier, you can even implement tech notation in your questions. How did I create this? I use LibreOffice Calc, which is also open source. I like open source. I do everything. LibreOffice is sort of a open source counterpart to Microsoft Office, right? All right, so here's our question again. And here's that may seem a very ugly interface, but this is a LibreOffice interface that we are using here. First thing to note, everywhere that's a yellowed area cannot be edited, all right? Everything else is the input of the user. And it's simply this. This is the main text of the question. And in that main text, may be hard to see, but what we have is some double square brackets to indicate, read the question. Wherever you see a double square bracket, it will be prompted to put in some numerical information rather than that. And so the program reads it, it looks for those, and it identifies those three variables, which would be in, if I go back to the question, it's the same, what would have been here would have been those square brackets, and the square brackets would have been here, and so forth. And then what it then does, we can also use Google ID, image ID to identify a file that you may want to put in your question. And you don't have to know how to do embedding or anything. The calc program will do the appropriate coding for you. So here's what happens. After you've set what's called a base parameter or base parameters, for example, this first term, HW, I say in the questions, I want the students to see a number around 15, but plus or minus 5. And the last digit of that number should be multiples of 0.1. So it randomly creates 10 versions of that question for those three parameters. And then further on, here are the prompts for the answers. Again, you have a placeholder that indicates where the student would input their answers. The calc file reads it and identifies those parameters. And then in this row here is where I actually do my calculation for the base case. The base case is this row here. So I carry the information to this row, the base case, and simply, having done the base case, I copy the formula to the other 10. So I do not repeat anything. I just do it once, which is the procedure for that question, and I copy going down. And so here we go. Just another example. For example, 5. I think that's plus or minus 3. So that means a number between 2 and 8. And these are numbers between 2 and 8. The last digits are multiples of 0.25. Because engineering parameters aren't always single numbers between 0 and 9. It can sometimes be 10s, 5s. So we try and represent what is typical that measurement instruments might give. the answers that the student is to give. The student, you have to direct the student as to the precision of the answer. So for example, even though the calculator, that's calc, gives a certain precision, there may be a more appropriate precision that really you want the student to give. And so you identify that by putting that error here. So if the error is much smaller, you see a higher precision number. If the error is large, you see a lower precision number. What the XML file does is what the calc file does, it creates a sheet that creates this XML file. And all I do is copy these 13 cells to a text editor. Okay? I use Notepad++. I don't know if some of you know that text editor. So what you just saw in that sheet called XML right here, sorry, the sheet, those 13 cells were simply just cut and paste here. So this is the same information here, now translated into Notepad++ and saved as an XML file. If you look, you see 1.2 is brought over, for example. The answers are here, brought over. Here is a high precision answer, so 6 significant digits, while a lower precision one, this is 5 significant digits, okay? And you can see even lower precision if I went for the other variable called v here, okay? So finally, I want to show how I use questions like this. So those 10 questions are placed in a category and randomly assigned to students. I usually do 2 or 3 questions in an assignment. So there's only a 10% chance that 2 students would be on the same question. Only a 1% chance if it's a 2-question assignment, and only a 0.1% chance based on laws of probability. So it's not to discourage students working together, but it's to encourage students to crunch their own numbers, because everybody has the same question but really different numbers. So I'm still encouraging group work. Also, I have questions being students have multiple attempts and usually given significant time to do an assignment, 2 or 3 weeks. So they can do up to 4 or 5 tries. And what we do is, what we do is we allow students to redo their assignments up to 4 or 5 times. And each time they're given immediate feedback. They're told their overall score for the assignment. They're told what answers are correct or incorrect, or how close their answer is to the correct answer, but they're not given the correct answer if they were incorrect. And so a student can wish to redo the assignment, which if they do, they get a same question, different numbers. Encouraging them to do it again, because practice is a critical element to learning engineering. And why do I have it open so long and give them several attempts? It's to discourage procrastination. So if you know you can do it more times than one, then it's likely you'll start earlier, so you can get the chance to do it more than once. So here is a graph. It may seem a little confusing, but there's just some things I'd like to capture here. So I had a class here of 58 students. Only 53 did the assignment. Not sure why the others didn't. And these circles here at 0 represent when the student accessed the assignment. Even though it was available for about 3 weeks, typical students, only about 12, if you count these circles, only about 12 of the 53 students looked at the assignment for the first 2 weeks. And then the other 40 panicked and started to look at their assignments. And I gave them 5 attempts. So not only, about, what's this, 40% or so only tried once. And some did twice, and some went all the way to 5 times. Interestingly, those who tried 3 attempts did best. You would think that those who did most would do best. So it's interesting. But there are some things to learn here, though. It's not to say less attempts don't help, because I want to show you something. So this is the best grade based on number of attempts. Okay? So persons who did 3 attempts generally had a better grade. This is the average grade of an attempt. So even though this is the best grade for persons who did 3 attempts, this is the average of all third attempts. That means it includes persons who did 5 attempts and who did 4 attempts also. All right? So what we see still generally is that it does go up with more attempts. Another bit of information is for persons who did 2 attempts, their second was better than their first. For persons who did 3 attempts, their third was better than their second, which was better than their first. For persons who did 4 attempts, their fourth was better than their third, and so on. So what happened is when a student felt they didn't care to do it any further, they just didn't try, for example, to do a 4th or a 5th attempt. That's all. 5th, we see a little dip, but I think some of these guys, the 5th guys, they're being a bit strategic. So they may intentionally put some wrong answers into their, to learn from the wrong answer to get a better answer going forward. So this is all efforts. Looks like a very jumbled graph, but what this line represents, it's the average around, let's say, a little window here. I averaged all these. Let's say I'm here, I averaged everybody in this little region and so forth. What this is the increase in a student's grade with an attempt based on how long they gave themselves to do the attempt. Based on how long they gave themselves. So, let me give you, so you can see it's pretty much a straight, it's called a log linear line. So you realize this isn't really, this is a log scale here, log linear. So what is this saying? And literally students will try and do a whole assignment in 2 minutes when they're panicking. But it's just saying, if you try and do this, if they try to do the assignment in 2 minutes, their grade won't increase, right? Let's say they gave themselves an hour to do an assignment. Their grade goes up by about 15%. That means if the previous grade was 40 and they gave themselves an hour to try again, it will go up to 55, average. Gave themselves 24 hours. Their grade likely will be twice as good as those who gave themselves an hour. A week, up to almost 40%. And then after that, we see diminishing returns. Okay? So you go forever, you still won't get it up much more. So, I've learned from this experience the benefit of having students be able to, 1, practice, and 2, use more time. So practice repeating an effort or repeating an assignment, and 2, give yourself more time to repeating the assignment. And I'm hoping to use graphs, not necessarily graphs like that one, but visually show students to encourage them, show this is how it's been. Those who gave themselves more time did better. I think it's also important to note, sorry, let me go back, that students who did very well did the worst at their first attempt. So the number 3, the persons who did 3 attempts, they were at the bottom of all their attempts, but they chose to practice and ended up doing better than the rest of the class. So even though they started as the worst, they did much better. Here are some limitations of this system though. The LibreOffice files are quite bulky. It's a spreadsheet file, so every cell is a bit of information that must be stored. So I'm thinking of using the same, let's say, algorithms from the XML, from the calc, and carry it over to a simple programming language. Being an engineer, we are sort of biased to MATLAB, so I probably will do it in MATLAB. This does not allow partial credit based on approach. So I'm thinking if I could work with Moodle or whomever on MATLAB. MATLAB has Moodle integration to develop an AI tool that allows students to give feedback at the end of an assignment. And that feedback feeds into a database that allows, so it's not my feedback. I've been hearing a lot about feedback, but I've been more hearing the feedback of the instructor. But I think the feedback of the students can assist other students. So by having students share how they approach a problem, it can help other students in how they should or shouldn't approach problems. And you can use that in real time, sort of. That means for a current assignment, the feedback of a student can help another student in that same assignment. Or for the same question in a future semester, you can use past experiences to help guide students going forward. So that's about it. It's not about wrong and right. And so, setting up chatbots that can have a discourse with the student is very important. Thank you for your time. Sorry for going over.